Hey everybody, it's time for some more science. So Mr. Plantt here, and we are going to kind of do a quick little review over density in the states of matter. From our margarine, our butter lab that we just did, we started to see this idea of density when we talked about how the oil separated from the water, and we started to see this idea of the states of matter, how we went from solid butter to liquid butter, and I guess technically liquid oil and water. So, to start this review, we got to talk about the idea of density. And we kind of had the idea from our lab that less dense things float on more dense things. So when we had our oil and water, the oil was less dense than the water, so the oil was on top. The official definition for density is the ratio of mass to volume. So really, if we have something that has a really, really big volume, and a really small mass, it'll be not very dense, be very, very low density. If we have something with a really big mass and a really small volume, it'll be very dense. So if we have big mass, small volume, we get high density. And then on the flip side, right, if we have a low mass and a high volume, something's really, really spread out like a piece of paper, we have something that has a low density. And so one way we can think about this is two boxes with the exact same mass. Right? So we're going to have a small box, and its mass is going to be, let's say, 50 kilograms. It's kind of a random number. And then we have a big box, and its mass is also 50 kilograms. Okay, so the volume is bigger on the box on the right. So let's label that, right? Let's not use blue again. Let's use this color, right? So this is a big volume, and we don't really care about the number right now. Right, just a big volume, and this is a small volume. So if we're trying to compare the densities of these, we would have the same mass with a smaller volume is going to be more dense. It's going to have a higher density because it's all of that mass packed into a smaller space. If we think about the bigger box, so the bigger volume with the same mass, well, now that all that mass is spread out to a bigger space, and so we get something that is less dense. So if we think about our butter lab really quick, we kind of had this test tube full of butter, and we had a line here where there was water, and then we ended up with a line above it where it was this kind of yellow stuff, and that was the oil. Well, in this case, we had the more dense, in this case, was the water, and the less dense was the oil. And that's really what we need to be focusing on right now, is just in comparison to things, which one is more or less dense. And so in this case, the more dense thing always is below the higher dense thing. And that's true for liquids, solids, and gases. So that idea of liquids, solids, and gases brings up our next point, and that is the states of matter. You should be pretty familiar with these. They kind of come up in science all the time. And so we normally know of the three states of matter, solid, liquid, and gas, but there's actually a fourth one and sometimes a fifth one, but we're going to just talk about the fourth one. So our first state of matter is the solid. And there is an order to these, and I'll explain that here in a second. But the solid is just when our atoms, these little circles that I'm drawing, are really tightly bound together, and they can still move, or they kind of vibrate back and forth a little bit, but they can still move, but they hold a definite shape. The shape, it's like a rock, right? Doesn't matter if you put a rock in a bowl or a rock in a cup, doesn't matter what container you hold the solid in, it has a definite shape. And that is when we have a solid, right? The atoms vibrate a little bit, but they're stuck together. So as we move up from a solid, we get something called a liquid. Now, liquids are characterized by their ability to flow. So these atoms now kind of flow by each other. They're not bound to just vibrating next to each other. They can flow past each other, and on the bigger picture, they take the shape of their container, but they have a set volume. Their volume doesn't change, but they do generally take the shape of their container. Right, those are our liquids. And so our energy goes up a little bit because these particles are moving more. That's kinetic energy. It's the kinetic energy theory. So these atoms are moving more, the particles are flowing by each other, and they're starting to increase their speed a little bit, and that's a liquid. And the cool thing about this is that as to go from a solid to a liquid, we have to add heat. We get that energy to increase by adding heat. So like our stick of butter, we added heat to get the liquid butter. And if we kept adding heat and kept that whole process up, we would get to a gas, where now the particles are flying by each other, right? They completely, their volume is dependent on the container they're in, and they completely fill whatever container in there, no matter what. They evenly spread out across their whole container. Right? That is a gas. And so now there's lots and lots of energy in those particles. They're moving really fast. They're flying by each other, and we're able to increase the heat even more to get that, and we get a gas. Now, one of the ones you might not know about is if we keep adding energy. If we keep adding energy to this gas, eventually we get to the most common state of matter in the universe. Way more common than solid, liquid, or gas, and that is a plasma. Right? And a plasma, it's kind of hard to draw it much differently than a gas, but the big idea for a plasma, which is the state of matter that we have in stars, anytime we have that really, really high heat, the big difference now is they're moving faster, and now they're ions. They're charged, and they're moving a lot faster. And that's when we get to a plasma. And so the order I did this in was kind of on purpose. Right? I wanted to show you guys that we have two things increasing from solid to plasma. So we have two things that start low on the left side by solid and get to high on the side by plasma. And those two things are, we'll do it in this cool pink color, temperature and energy. So temperature and energy both increase as we move from solid to liquid to gas to plasma. So to get a solid to turn to a liquid, we have to increase the temperature, which by turn increases the energy. And then to go from liquid to a gas, we have to increase the temperature again and increase the energy again and move to a gas. And if we keep doing that to the gas, we'll eventually get to a plasma. Right, so a couple quiz questions that you might be seeing coming up, right? Or which one of the states of matter generally has the lowest temperature? Well, that'd be a solid, right? Which one of the states of matter generally has the highest energy? Well, that'd be a plasma. And then we can do that. It's kind of hard. What we can't do yet is compare these across materials. Like, what has more energy, solid ice or solid metal? Okay, it's hard for us to compare those numbers right now, so we'll usually just stick to one material. But that's the basic gist of this review, guys. We have a little bit of density, a little bit of how things float on top of other things, even if they're solid, liquid, or gas, and then a quick review on solids, liquids, and gases. Next week, we'll get into more of the phase change, so more of changing from solid and liquid to gas, and what those are called, and how the energy changes, and we'll kind of do more of that on our third unit. Alright guys, so make sure you have good notes written down, that you've drawn your pictures, pretty much drawn everything I've drawn, and maybe even added notes of what I said, because that can help when you come back to your notes, help remind you of how these things work out. So I wouldn't be upset if I saw kind of this whole picture on